Okay, this is the homework for the 6.3a. Number one, they want you to simplify if possible. So we have subtraction of two cube roots. So remember, in order to add or subtract radicals, you have to have the same index and the same number inside the radical, which both of these do. So 6 cube root of 3 minus 2 cube root of 3 is going to be 4 cube root of 3. And that's your answer. Number 2, it's a lot like number 1, but this one is not simplified yet. So we want to break down some of these radicals first, and then take a look at them and see if they have the same index and number inside to see if we can add them or not. So the cube root of 81 we can break down. 27 is a perfect cube, so we're going to break that, and that we can simplify. And then the cube root of 54, 27 again, is the thing that we're going to be able to simplify, and that's 27 times 2. So if I break that down, the cube root of 27 is 3. 3 times 3 is 9, so we're going to have 9 cube root of 3 minus cube root of 7 is 3. 3 times 2 is 6, so 6 cube root of 2. And that's it. We can't simplify this anymore. We can't subtract them, because even though they have the same index, 3 and 3, they don't have the same numbers inside the roots, so we can't go any further. Number 3, it's a binomial squared, so what we're going to do is we're going to write this out side by side. That forces us to remember that we have to FOIL it out. We don't just square the first and the second and then add them and then call it a day. We don't do that. That's not, you wouldn't get the right answer. In other words, look back at your homework right now, and if you got 8 as an answer, that's what you did. You squared the first and the second, made it 3 and 5, and then you added them and got 8. That's not correct. You have to write it out separate, and you have to FOIL it out. So root 3 times root 3 is 3. Root 3 times root 5 is root 15. Root 5 times root 3 is root 15. And root 5 times root 5 is 5. 5 in the 3 is an 8. Root 15 plus root 15 is 2 root 15. And that's your answer. Number 4, multiply the conjugates. So because they're conjugates, we don't have to do all 4 steps of FOIL. We can just skip and do the F and the L in FOIL. The F in FOIL will give us 2 root 6 times 2 root 6, which is 4 times 6, or 24. The reason why that happens is 2 root 6 times 2 root 6. We get 2 times 2 is 4. Then we get root 6 times root 6 is 6. 4 times 6 is 24. Then we have a positive 8 times a negative 8. That's a negative 64. So we have negative 40 as an answer. Okay, for number 5, they want you to rationalize the denominator. So the first thing you want to do is simplify anything that we can here. So I'm going to simplify the root 8s. Remember, the square root of 8 is the square root of 4 times the square root of 2, which is 2 square root of 2. So the numerator is 3 plus 2 root 2, and the denominator is 2 minus 2 times root 8 would be 2 times 2 root 2, which would be 4 root 2. So in order to rationalize, we're going to multiply the top and bottom by the conjugate. So 3 times 2 is 6. 3 times 4 root 2 is 12 root 2. 2 root 2 times 2 is 4 root 2. And 2 root 2 times 4 root 2 is 8 times 2, which is 16. The denominator, we just have to F and L it in FOIL, so 2 times 2 is 4. And negative 4 root 2 times positive 4 root 2 is negative 16 times 2, so negative 32. So we're going to have 6 plus 16 is 22. 4 root 2 and 12 root 2 is 16 root 2. And 4 minus 32 is negative 28. 22, 16, and 28 are all divisible by 2. So that's 14, that's 8, and that's 11. So we could write down 11 plus 8 root 2, all divided by negative 14. And that's your answer. This one is a lot like the other ones. We just have to FOIL this out. So root 3 times root 3 is 3. Root 3 times 2 root 7 is 2 root 21. Root 7 times root 3 is negative root 21. And then negative root 7 times positive 2 root 7 is negative 14, because 1 times 2 is 2, root 7 times root 7 is 7, and 2 times 7 is 14. So 3 minus 14 is negative 11. 2 root 21 minus 1 root 21 is 1 root 21. And that's it. Number 7, simplify. So we have a lot of variables with different exponents here. So the first thing I notice is that s to the 4th divided by s to the 4th. That's the same thing divided by itself, so that's 1. That can cancel. R squared divided by r cubed is r in the denominator. And the reason why is because 3 is larger than 2 by 1 degree. So it's r to the 1 down here. T to the 6th divided by t to the negative 6. Well, if I move this up, I'm going to get t to the positive 6 up here. So t to the 6th times t to the 6th is t to the 12th. And that's it. Number 8, factor to solve. So we already know that it's factorable, or else it wouldn't say that. So let's use the box method. 6 times 3 is 18. We're going to do 2 and 9 because they have a difference of 7. The different signs, the larger one is negative. So we're going to have 2x and negative 9x. Negative, positive, positive, positive. This factors out to a 3, 2x, 3x, and 1. So we're going to have 3x plus 1 times 2x minus 3. This gives me a 0 of negative 1/3. This gives me a 0 of 3 halves, and that's it. Number 9. Find the solutions of the equation. Well, it's in a quadratic form because it goes x to the 4th to an x squared down to the constant. The thing that you should notice is that if this and this are both perfect squares, so the first thing you should check is to see if it's a perfect square trinomial. The square root of this is 5x squared, and the square root of that is 4. 5x squared times 4 is 20x squared. If you double that, you can get 40x squared. So it is a perfect square trinomial. So how would you write that? Well, the square root of that is 5x squared, so you put that in the first one. You take that sign, put it in the middle, then you take the square root of 16 and you put that here. Then we want to solve for this. So 5x squared minus 4 equals 0. If you add 4 and divide by 5, you get x squared equals 4/5. then when you take the square root of both sides, you get positive negative root 4/5. If you break that up, you're going to get positive negative 2 over the square root of 5, because if you split this up, it's root 4 over root 5, and the root 4 is 2. You have to rationalize this, so you have to multiply the top and bottom by root 5. So we're going to have 2 root 5 over 5, positive or negative. Now if I only took these two, that would mean that there would be 2 zeros, but we know that there's going to be 4 solutions based on the highest exponent. Remember, the 5x squared minus 4 was a double root in and of itself. So this is a double root and a double root. So 2 root 5 over 5 is a double root, and negative 2 root 5 over 5 is a double root. That's going to give you 4 solutions. And last but not least, what is a rationalized denominator? Well, I'll start by giving you a couple examples of denominators that are not rationalized. For example, 3 over root 2, or 1 plus I over 2 minus 3i, or 4 over 1 plus root 3. These are all examples of denominators that are not rationalized because you either have an irrational value or an imaginary value in the denominator. So what you would say is a rationalized denominator is a denominator that does not contain any irrational or imaginary values.